This video is for section 7.5. It's going to cover complex fractions and what you can do and how to reduce those. So a complex fraction is a fraction that also has fractions in the numerator or denominator. Meaning it has like a fraction within a fraction or multiple. Denominator. Well, you can rewrite it as a division problem to help you reduce it. So these top four are all complex fractions because they either have a fraction in the top, the bottom, or both. So this is complex even though it's there. So the big purple line is like your big fraction, and then you have other fractions. Division is, or a fraction is a division problem. So we could rewrite this same thing as 3/4 divided by 9/8. And then we learned how to solve this by keeping the first, changing it to multiplication, flipping the second, and then multiplying. So we would get 24 over 36, and those are both divisible by 12, so we would get 2/3. With mixed numbers, the biggest thing is before you can divide, you need to turn them into improper fractions. So I'm going to rewrite this as a division problem. Then to turn these into improper fractions, you multiply the numerator times the whole number, and then, or denominator times the whole number, and then you add the numerator. So 4 times 3 is 12, plus 3 is 15. The denominator stays the same. Then we're going to do the same thing here. 2 times 1 is 2, plus 1 is 3. Denominator stays the same. Now we're going to use these improper fractions to solve the problem. So we would keep the first, change it to multiplication, flip the second. 15 times 2 is 30. 4 times 3 is 12. Those are both divisible by 2. So we get 15 over 6. Those are both divisible by 3. So I get 5 over 2. You can leave it like that. You can write it as 2.5. You can write it as 2.5. Whatever works for you. The same thing happens when you have variables. So you take the first, divide by the second. To do that, we keep the first, multiply, flip, and then multiply across. So this would be 2xy over 12. 2 and 12 are both divisible by 2, so we would get xy over 6. If you have binomials or trinomials or any of that, you're going to factor or distribute, multiply it all out so that you can simplify. So this is x minus 1 squared over 4 divided by x minus 1 over 8. If I rewrote the top of the first, squared just means there's 2 of them. We're going to change that to multiplication, flip the second, and we can pre-reduce. So we have an x minus 1 on the top and the bottom. 4 divided by 4 is 1. 8 divided by 4 is 2. And if we multiply, we're left with 2x plus 1. 2x minus 1, sorry. So this is the same thing. We just have an addition problem on top and a subtraction problem on the bottom. The simplest way to do this is to simplify the top as much as you can, simplify the bottom as much as you can, and then do the division problem. So for us to do the addition, multiply the first fraction by b over b. So I would get b over ab. Multiply the second fraction by a, I get a over ab. And if I combine those, I get a plus b over ab. You could have written b plus a because that's the order they're in. It doesn't matter. You can add in any order. So now we have a new numerator. Let's do the same thing on the bottom. Multiply this by b. So we get b over ab. Multiply this by a. So we get a over ab. And if we put those together, we get b minus a over ab. So now we have the two fractions. So we can rewrite this as a division problem. A plus b over ab divided by b minus a over ab. Keep the first, so we have a plus b. change it to multiplication, flip the second. Now we're going to reduce, and we have a plus b over b minus a. And that's as far as that one can get simplified. So even though it looks crazy, scary, and complicated, we're just doing adding and subtracting followed by dividing. So if you want, you should pause, try the next three, see how you do. Check in one at a time or all at once, it's up to you. Okay, so if I was going to do the top on this one, it would be x over 1 minus 4 over x. So we'd multiply this side by x, and we would get x squared over x. Multiply this side by 1, which would just end up with 4 over x. Combine like terms, we get x squared minus 4 over x. And then if I were to factor that, it's a difference of squares. So we have x plus 2, x minus 2 over x. Bottom, we're going to do the same thing. Put the first number over 1. Then multiply the first fraction by x. Multiply the second fraction by 1, meaning it stays the same. Add our fractions. That has a plus, so we can't simplify it. So we're going to leave it just like that. Now we have our new complex fraction. So we have the top divided by the bottom. Now I know the bottom one's going to flip. So to save a step of writing, I'm just going to automatically flip that one as I go. That's an option for you. Then I cancel anything that I can and write what's left. So x plus 1, or x plus 2, x minus 2, and then x squared plus 4 on the bottom. All right, let's check out the next one. So if we start with the top, we need to multiply the first one by x minus 1. So we get x minus 1 over x times x minus 1. Multiply the second one by x. So we get 2x over x times x minus 1. Combine like terms on the top. 2x plus x is 3x. So we're left with this as our new numerator. Do the same thing on the bottom. Multiply by x minus 1. So we get 2 times x minus 1 on the top. And then multiply this one by x. So minus x. Both of these are going to be over x times x minus 1. On here, we need to distribute. So 2x minus 2 minus x over x times x minus 1. Let's see. I'm just going to slide this a little further. There we go. And now if I combine like terms, 2x minus x is 1. So we have x minus 2 over x times x minus 1. Now if I were to keep going, we'd have the first one divided by the second. So I'm going to multiply and flip. And these are going to cancel. So we're left with 3x minus 1 over x minus 2. Now, you may or may not have noticed that when you have the same denominator on both fractions in the complex, they're always going to cancel. So you could skip straight to this step if you know that or notice that. You do not have to. That's kind of a personal preference in how your brain works. All right, let's try this last problem. Going to multiply this one by y. So I get y over xy. Multiply this one by x. So I get x squared over xy. And if I combine like terms, I get y plus x squared over xy. Now let's do the bottom. Multiply this by y. I get y over x squared. Multiply this by x squared. X squared y. There we go. Multiply that, we get x squared over x squared y. And when we combine like terms, we get y minus x squared over x squared y. So those denominators are not exactly the same. So we're going to write out the whole thing. Y plus x squared over xy times x squared y over y minus x squared. Now, If we don't pre-reduce and we go straight across, we would end up with things on the top and the bottom and start to cancel. So I have a y that's multiplied and a y that's multiplied, so those cancel. On top I have an x squared, on the bottom I have an x, so if I divided, that would just change to x to the first. And then these are different because one's plus and one's minus, so they just stay exactly like that. So there's our top and there's our bottom. And that's our final answer. Let me know if you have any questions.